Hi, and welcome to this brief introduction to the CAN bus with the Teslax CAN Explorer app for iOS. Just a quick note, if you're watching this video, then you probably are interested in connecting an accessory to your vehicle to snoop on CAN bus data. Please do so at your own risk. Improperly used, these devices can interfere with the traffic on the CAN bus and cause undesirable behavior in your vehicle. Some devices require additional wiring, and in the end you could do damage to your vehicle and void the warranty, so please proceed at your own risk. Modern vehicles are a collection of computers. For example, a computer that controls your motor, monitors your battery, or provides access to the entertainment features in your car. These devices are often connected with a controller area network, or CAN bus. In 2008, manufacturers were required to implement OBD2 with CAN. This means you may be able to connect an accessory directly to your OBD2 port and start monitoring. It should be noted, however, that not all OBD2 ports are the same. For example, early Tesla Model S's included an OBD2 port just for show, and the CAN pins were not actually connected. In such cases, you may need additional adapters or harnesses installed in your vehicle to provide access to the CAN bus. Some accessories, such as Josh Wardell's CAN server, can be connected in-line for easy installation. Most vehicles have multiple CAN buses, and the devices on each network may be different. For example, the Supplemental Restraint System, or GPS receiver, may be connected to a second bus. Advanced users may wish to monitor multi-buses simultaneously. This may be easy if your vehicle has multiple CAN buses exposed at the OBD2 connector. This is often not the case, and usually you will need custom harnesses and wiring for a multi-bus setup. You will also need a multi-bus accessory, such as the Comma AI Panda White, which supports up to 3 buses, or a 2-bus version of the CAN server. Comma AI has deprecated support for Wi-Fi on the Panda, so you'll need to run an older firmware to connect to a Panda. The Panda also has a more involved connection ceremony, and for these reasons, it's only recommended for the most advanced users. In general, multi-bus monitoring is not necessary, since most of the interesting data is often available from a primary bus. For example, the vehicle bus on the Tesla Model 3 contains most of the information users will be interested in. That said, there are a few signals of interest on the Model 3's chassis bus, such as lateral and longitudinal acceleration values and the GPS coordinates. A single bus setup will not provide values to Teslax, and any gauges and pages with these signals will not update when connected to a single bus source. The data on the CAN bus is a stream of bytes. This stream can be broken down into frames. A frame consists of a message ID and a payload. Teslax supports passively monitoring CAN bus data for networks with 11-bit message IDs. Buses with 29-bit IDs are currently not supported. The payload is still not super useful. We need to know how to decode these into useful values. A DBC file is a description of the frames you might find on a CAN bus. Entries in this file explain how to decode a CAN frame into useful values. In this case, we have a message ID 257, which is 599 in decimal. Looking at the DBC file, we see this is the DI speed message, and the signal entry tells us that the vehicle speed starts on the 12th bit and is 12 bits long, and it contains other useful information on how to decode the value. This gives us a value of 48 kilometers per hour. The only problem? The DBC information is often not provided by the manufacturer. Communities of vehicle owners will often try to figure out the decoding rules for their vehicle of choice. Teslax provides a few example presets, but does not maintain a library of presets for all vehicles. Users who purchase the Extra Strength feature set can import DBC files and configure widgets. This allows users to keep their signal database up to date with the latest information provided by the community without waiting for an app update. Teslax supports 3 types of accessories: Bluetooth Classic, Bluetooth Low Energy, and Wi-Fi. These accessories use one of 3 protocols to communicate. Since iOS requires MFI certification for Bluetooth Classic accessories, the only Bluetooth Classic accessory that is supported is the OBD-Link MX Plus. Devices like the V-Linker MC Plus do support Bluetooth Classic and BLE, but since they are not certified, only the BLE is supported by Teslax. The ELM327 AT command set is prevalent in the accessory market. These devices are common, but they're often slower and do not support filtering. Accessories that support the ST command set are often faster and support filtering. This provides a better experience. Finally, the Panda protocol supports multiple buses over Wi-Fi. These are the only accessories that currently support multiple data sources simultaneously from more than one bus. Another consideration is security. Many AT and ST command set accessories will let anyone connect. This means someone could walk up to your vehicle, find a network or Bluetooth accessory, connect, and then send commands to your vehicle. The MX Plus has an explicit pairing to prevent this. The Panda protocol devices have Wi-Fi passwords to prevent this. For more information, please see the supported hardware page on the Teslax website. In summary, proceed with caution when connecting accessories to your vehicle and do so at your own risk. Additional wiring and harnesses may be necessary, and you could damage your vehicle or void your warranty. Vehicles often have multiple CAN buses, and not all data is available on every network. Most, but not all of the interesting data is usually available from a single bus, however. Accessories have different capabilities and performance characteristics, so choose the right accessory based on your needs. Thanks for watching, and please check out Teslax 2.0, now available in the App Store.